All right, so 7.2a, number 12. So it gives you this crazy drawing. Did you guys know that was called a penny farthing?
Yeah.
Did you? Yeah. It's a good fact to know. You can drop that at dinner tonight. Hey, Mom, can I have a penny farthing? All right. Let's see. So the biking guard is called a penny farthing. All right. So there's more to it. All right. So the bike rolls from rest down a hill. So the front wheel. So here's what it tells us. It tells us that the front wheel has the following stuff. It's got a radius of 1.2 meters. It achieves an angular velocity of 9 radians per second. By the time the bike gets to the bottom of the hill is 50 meters long. And the back wheel, oh my glob, and the back wheel has an angular acceleration of 3.43 radians per second squared. Okay, so here's the deal, you guys. Problem-solving strategies. This chapter is really tough in that, like, with the last chapter, it was like there's two types of problems, right? There's two equations for work, which I just erased today. There's two equations for work. You're always going to use one equation to find the work and then plug it into the other one, right? Like that was that last chapter, right? This chapter is like, holy cow, there's a gazillion equations. So I can't sort of say every problem is set up this way. But here are some strategies that you can use that will help you be more successful, okay? The first thing you always want to do is, as you're writing out your givens, anytime you run into something that's not meters, radians, or seconds, convert it, okay? So if I give you rotations per minute, convert rotations to radians, minutes to seconds. Okay? If I give you the speed of a car in miles per hour, convert miles to meters, hours to seconds. Okay? If you did not take chemistry and have not learned dimensional analysis, please, please, please let me know. A couple people have already approached me, and I'll do a quick crash course on how to do that. Okay? How to do those conversions. Please let me know, because you're not going to be successful if you don't know how to do that. All right, so that's thing one. Step two, write out the givens. Well, so step one, first of all, I think we're done with that here, right? Because everything in this is meters, radians, and seconds, right? Step two, write out the givens. So I've sort of done that, but I haven't identified what they are. Okay? So over here, I made a list of all the different variables we're studying in this chapter, along with their corresponding units. Okay? Because I've had a couple people write, like, oh, omega is 7 meters per second. And that can't be right, because omega is an angular value. All right? So with that in mind, this 9 radians per second, what is that? What's it a measure of, you guys? Sure, we got it. Good, that's the angular velocity of the front tire. Now, you got to read the problem a little bit more carefully here, because there are different types of angular velocity, right? There's initial, final, and average. Which one is this? Let's read it again. Let's see. The bike rolls from rest. Ooh, there's something I didn't write down. Down a hill, so it achieves an angular velocity of 9 radians a second by the time it gets to the bottom. So is this the starting angular velocity or the ending? Ending. What is the starting? 0. Cool? Everybody cool with how I got all that? All right, what's the 50 meters, you guys? How far the bicycle traveled. That's the same as the distance a point on the outside edge of the wheel traveled, right? So that's our linear displacement. How do I know it's delta x and not delta theta? Because it's meters. It's a linear quantity, right? Delta theta would have to be in radians or rotations, but we then convert it. Yes?
How do you know that, like, the one wheel rotation was 50 meters, and what if it was like a rotation and a half?
Say that again? No, I'm not saying that's one wheel rotation. I'm just saying that's how far the wheel went.
Oh, okay.
I don't know how many rotations that is.
Okay.
Does that make sense, you guys? I have no idea how many rotations this corresponds to. All I know is that the bike rolled from the top of the hill to the bottom of the hill, and it was 50 meters. That's how far it went. Cool? All right. Over here, it tells us that the back tire has 3.43 radians per second squared. So what's that a measure of, you guys? Angular acceleration, right? All right, as a quick note, if you look at your equation sheet, it is a little bit difficult to tell the difference between the A's and the alphas on that sheet because of the way the computer prints out alphas. Okay? On the sheet, your alphas look a lot like A's, but then it's got another little like boop up at the top. Okay? So just watch that. The other thing is, every time there's one, all of the ones in the angular column are alphas. You know what I mean? And then the jumper equation, it's A equals alpha R, because it's linear equals angular times radius. Cool? All right. Okay, so this is what we know. And so the question wants us to find the radius of the back tire. All right, so any questions just on how I got this far? Okay. So the only equations we've learned this chapter that have radius in them, I'm happy with that sentence, are the jumpers, right? So what the jumpers do is they connect linear quantities to angular quantities, right? So if I can find one quantity, this is going to be, if I can find one quantity for which I know both the linear and angular counterparts.
One equation.
Yeah, so like if I can find either both the linear displacement and the angular displacement, or the linear initial velocity and the angular initial velocity. You know what I mean? Follow? Then I can find the radius, right? What's the only thing I know about that back tire?
Angular acceleration.
The angular acceleration. So what do you think I probably need to find? I heard a bunch of people say some stuff about the front tire. Would knowing the angular acceleration of the front tire help me? Yes. You're saying yes, so how come?
You can find the normal acceleration from it.
Okay, cool. So that's at the crux of this, right? So the issue is, remember you guys, the angular quantities for the wheels are going to be different, right? But they have the same linear quantities, right? So if I can somehow find the linear acceleration for the front tire, then I'll also know the linear acceleration for the back tire. And then I can use A equals alpha R and find my radius. Does that make sense, you guys? Okay. And so if you're exactly right, there's a couple of ways we can go about that. So questions before I proceed? All right, so let's go back to our list over here. Convert to radians per second, meters, radians, seconds. Check. Step 2, write out givens. Check. Step 3, decide angular or linear equations. So somehow I got to find this linear acceleration for the front tire. And the information I'm given, I've got some angular and some linear. So we need to convert. We need to get everything to sort of agree, right? When you use an equation, you got to be using either all linear values or all angular quantities. Okay, I've seen a few people use like linear velocity but angular acceleration in one equation. You can't do that. It's either all linear or all angular, unless you're using a jumper. So, thoughts about how we can get through this? I see a few ways of doing it. How about this? So here are the two ways I can think of to do it. Option 1, use jumpers and convert these to linear velocities. Right? VI is going to be 0, so you're really just finding VF. And then we can use the 2A delta x equation to find A. Follow? Or convert this to angular displacement and then use the angular counterpart for that same equation. Follow? All right, so let's do this. View, dual page, on. Cool. So I'm going to convert. So if omega f is 9, then I can do this. Vf equals omega f times r, right? That's one of my jumpers. Follow you guys or no? Lots of blank stares. All right, so we got 9 radians per second times our radius is 1.2 meters. So 9 times 1 1/5 is what, 10.8? Is that right? Meters per second. So there's my VF. What's VI going to be, you guys? 0. If omega I is 0, then vi is 0. And I know my displacement is 50 meters. So we can use 2a delta x equals vf squared minus vi squared and solve for a, which I will do now using this calculator. Clear. 10.8 squared divided by 2 divided by 50 gives you 1.16. 64 meters per secundo squardo. Follow? Any questions? All right, so that's the linear acceleration of the front tire. That's the worst 6 ever drawn by a human being. You weren't invited. Okay, so now what? Yeah, we're kind of skipping a little step. So then you go, oh, and the linear acceleration of the other tire is the same, right? Because they're all part of the same bike, so they have to be accelerating at the same rate. And now we can find our radius, right? Follow, you guys?
Sorry, what's your final answer right there in that acceleration?
I don't know. Oh, this one?
Yeah.
1.1664? What do you mean? Or do you mean for...
No, I was confused. Like, I didn't see decimal.
Oh, gotcha. Yeah, my decimals are crappy. You good, Lester?
Do you have to use information from both like the front and back tires to get the answer right? Because I think, or no?
I don't know another way of doing it. Well, that's not entirely true. I do know some super secret ninja shortcuts, but I don't know the... I think I'd confuse more people than helping by sharing that.
Alright, so how did you use the back tire to solve it? Did you just use the jumper equation?
Say that again? You can't. That's what I'm saying.
Oh, so you didn't use the back tire information?
Yeah, I did. So I used the front tire to find the linear acceleration of the front tire, right?
And that's the work in red on the right side?
Yep, so everything here in red is about the front tire.
Okay.
Okay? Then I said, oh, well, if the linear acceleration of the front tire is 1.1, then the linear acceleration of the back tire is also 1.166. You good up to there?
And then it already gave you the 3.43, and then you can solve for R.
Yeah, exactly. And then you go, oh, now I know A is alpha R. I know my A because I just found it. I know my alpha is 3.43 radians per second squared times R, and divide. And that gives you your R of, what is the answer, you guys? 0.34, thanks. Cool, you guys? All right, so the only thing that this problem doesn't have that is a thing you ought to be able to do is this first step. All right, so if I give you a number that's rotations per second, you got to convert. If I give you miles per hour, you got to convert. All right, the other thing I will encourage you to do is this last part. Once you get your answer, don't just write the answer down. Write down what it is. Okay? In this problem, I found the radius of the back tire. And if there was a part B, it's possible that you might need that radius to solve part B. There isn't a part B here, but if there was, that would be a thing. Cool? Questions? Okay, so that is that. All right.